Okay, so here we're doing exercises for the binomial distribution. And we're doing problem number 2, still continued. And so what's problem number 2? We toss a coin 8 times. Let X be the number of heads. Okay, so we found in previous videos that probability of X equals 0 equals, all right, let me first write these all out, then I'm going to fumble around to another piece of paper and write down the answers, look up those answers that we had from the previous video, and then I'll write them down. So, I don't know, maybe I didn't really need to do this. I can just look over. Did I need to rewrite this? Not necessarily, but it seems I'm doing that. Okay. So, for 0 heads, so no heads at all, this is what we get. 1 head, 2 heads, 3 heads, 4 heads. Yeah, okay. All right, now I've talked about this before. The probability of getting 0 heads is the same as the probability of getting 0 heads is the probability of 8 tails, and the probability of 8 tails is the same as probability of 8 heads. So these numbers should be the same. That's because the probability of head and tail are the same. The probability of 1 head is the same thing as the probability of 7 tails, and the probability of 7 tails is the same as the probability of 7 heads. And so there's symmetry to this whole thing. So the probability of 4 heads is the same thing as, I did it wrong. No, the probability of 5 heads is the same thing as 3 tails, and the probability of 3 tails is the same as 3 heads. So it should be this one. Okay, so then that's what we're supposed to do here, and then what we're going to do is we're going to sketch the graph, which is, look, without a calculator, it's, you know, like a graphing program, it's sort of sloppy stuff, which tempts me to take out a pencil. I can't find my pencil right now. Okay, so anyway, I guess I'm going to charge ahead with a pen, but it can be a little bit sloppy. So here we're going to sketch the graph. Of the distribution. Okay, this is called a probability distribution, or probability histogram. And, you know, there's different ways that people have of showing this, so they should all be about the same, but there's different ways to space things and so forth. Okay, now first of all, I'm going to round these out. Now the thing is that this is the probability X equals 0 is, well, let's just write this as moving the decimal over. We're going to write that as 0.4%. and this I'll write as about 3%. Okay, so I'm the first one I'm not going to round to the 1% because I'm going to have 0, so I'm going to not be consistent, right? That's 0.4%. The other ones I'm going to round to the 1% place. So that's maybe someone would not like that style, but that's what I'm doing here. So 0.4% is 0.4%. It's not the same as 4%. You know, they're different. Okay. Then, so the highest one here is 27. And so there's a question of how much space I should use. So I am going to have to come up with an executive decision how many each of these should count. I guess I'm just going to make each one worth 2. I could just keep going down farther. That's okay. So I'm going to make this 2, 4, 6, 8, 10%, 12, 14, 16, 18, 20%. 6, 8. I really like drawing also, but I somehow feel what I feel about, not guilty, a little bit though maybe, is that this is something that you just sort of have to decide on your own about how much spacing you have, and 2 people can have 2 different graphs that look nice, you know, or people have 2 different computer programs that do it, and they come up with 2 things that look pretty good, but they're different. Okay, I am going to start with. Okay, so this is how I'm going to write this. This is going to be like a bar graph, and I only have these discrete values of 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are the number of heads. Now, I made 2 squares in the bottom. Maybe I should have done 3. So this is the number of heads. And so when I do this, I'm putting the 0 right in the middle of that bar there. Now, after all this work, it's sort of a downer to get this all wrong by just a small mistake. But anyway, so 0, or it's 0.4%, so that's a little bit less than 1. So I don't know, I'm using a crayon. I thought maybe that would be easier to erase, but probably not. Okay, then I'm going to go to 3%. For 1, it's 3%. And then comes 11% for 2. So the spacing's up to you, but you know, depends on how much paper you want to use. It's a little bit of just a judgment, for sure. It's a judgment of how well you want to, how much you want to space it. Yeah, okay. So 27%, 22, 22, 24, 26, 27. And then back down to 22%. So we see that the most likely thing we can have is is to get 4 heads and 4 tails, because there's a 50% chance of getting a heads. But it's still sort of interesting that even though it's a 50% chance that you're going to get a heads, it doesn't mean that's going to happen all the time, that you're going to get 50% of the chance always get heads. So, it's actually, did I even do this right? 22, 24, 26, yeah. So even though it's the most likely thing that you're going to get even though the most likely outcome is that you get half the time heads, it doesn't happen all the time. So the next likely outcome is that you get 3 out of 8 heads or 5 out of 8 heads. Remember, 3 out of 8 heads means 5 out of 8 tails, and that's why you get, in 5 out of 8 tails, same thing as 5 out of 8 heads. So that's why you have that symmetry there. So this is just fumbling around trying to draw a good graph here, and then my pen's getting a little clogged up because I'm using crayons and pen. It's a mixed medium artwork here. And then actually I think I should put the bars here too. So maybe if I were doing it again, I would do the pen first and then color in with a crayon, just like I was taught in elementary school in the lower grades. Okay, so let's then move on to C. All right, and this is percent. Let's move on to C, which is describe the graph. This is extremely important for us to notice the obvious things about the graph. It's symmetric, and it's bell-shaped. So this tells us it's approximately normally distributed. And what happens is that there's a theorem that says that if you increase the number of coin tosses, then this will become closer and closer to being normally distributed. So that's a good one. Okay, then is there a D? Okay, on the graph above, shade in the region X between 2 and 6. Okay, so let's do that. So notice it's, when I say between, that's not as precise as what I'm writing down here. What I mean is X greater or equal to 2 and less than or equal to 6. So we're going to include 2, and I'm going to shade that in, and then 3, 4, 5, and 6. That's almost everything, really, but there's stuff that's missing. By the way, it's a pretty good idea to add on to this picture, which I think I'm going to do right now. This can make it look nicer, I think. Just putting this here. So let me write it like that. 3%, 11%, 22%. Oh, you can't see what I'm doing. 22%, and 27%. These are, you know, approximations. The thing is, I'm not really, I better work on a little bit harder shading this in. Okay, and so back down to D. D is going to ask us what the probability that we get between 2 and 6 coin tosses. All right, so that means what's the probability you either toss it 2, 3, 4, 5, or 6. And so this is equal to the probability that you toss a 2, probability plus probability you get a 3, probability of 4, probability of 5, plus probability of 6. This is using the sum rule of probability because each of these events is disjoint. You can't toss a 2 and a 3 at the same time, so you add those together. And so then I'm going to do, roughly speaking, looking at the graph, 11% plus 22% plus 27% plus 22% plus 11%. And then you can use a calculator, but I don't know why. I feel like I'm too cool to use it or something. I don't know. So let me see. 22 plus 11 is 33. Adding that to 27 is 60. 33 plus 27 is 60. 82. 93% around. Which, okay, see, another way of doing this anyway is to take 100% and subtract the probabilities of a 1, a 7, a 0, and an 8, and that's around 93% also. So you could subtract off the part you didn't cover from 100%. So also, so that's what you get 93%. Okay, so one way to interpret this graph, I mean, not just one way, what we should think of is that there's area under the curve, and the area under the curve corresponds to probability. The total area under the curve is 1 or 100%. So the total area is 1 or 100%. And then when we're looking at probabilities, we can calculate area. So calculating area under the curve is the same as finding the probability of an event. Calculus, just take the first semester calculus, you'll spend a lot of time finding the area under the curve, and especially second semester. So now this is not one where you use calculus though. You can just count this. Okay, and so that finishes that problem. So we found the probability, we sketched the graph of the binomial distribution. Where we have n equals 8 and p is 1/2. And then we shaded those parts that have 2, 3, 4, 5, 6, and we found that area just by adding this up, and then we got that that's 93%. Okay, that's all.